Okay, welcome to this particular lecture. We're going to be looking at the overview of software development lifecycle, SDLC. So by the end of this class, you should be able to define software development lifecycle, and you should be able to explain the different phases that we have in the SDLC. And finally, you should be able to discuss the importance of following a structured SDLC, that's software development lifecycle. Okay, so the software development lifecycle is a structured process used by software developers to design, develop, test, and deliver high quality software. So I want you to look at the different components that we have here. uh, is a structured process that the software development team uses to design, develop, test, and deliver. And of course, in the previous class, we discussed about the team makeup. Okay, so these people are saddled with a structured approach that they can use to design, to develop, to test, and ultimately to deliver high quality software. Okay, it's basically a step-by-step approach to software creation, which ensures that all the things that the software are meant to be doing are met in the design. Okay, so the aim is actually to be able to render a reliable, efficient, and maintainable software. So the SDLC, okay, provides a framework, a system that guides developers through the stages from the initial planning to the point of deployment and the maintenance of the software. Okay, we are going to be looking later the importance of following this structured approach. Importance of following this structured approach. And before we continue, I want you to make it a point of duty to start following this structured approach, even when you are doing small projects, because I want to believe that some of you at this point are already working on some projects. Okay, maybe freelancing projects or whatever. So before we proceed, it is very important that you do not just come across this class and then you go back. Maybe after this class, you write the examination, you will pass by the grace of God, and then you throw it away. Software development is such that you will maybe overcome a lot of pitfalls, okay, if you follow this structured approach to software development. So the development life cycle consists of several phases, and each of those phases plays a very important role in ensuring that the software development project becomes a success. So in the stages, we have the planning stage, we have the requirement gathering and analysis stage, we have the system design stage, we have the implementation and coding stage, we have the testing and deployment, and then maintenance stage. But basically, most of you are already working in this age, and um sometimes, or rather most at times, some persons think that software engineering or software development ends at this. So as you can see, implementation or coding is actually one out of the uh, seven stages or seven things that you have to do in the process of developing software. So the same way you have people that do the programming is the same way you will have people that specialize in system design and people that specialize in requirements gathering and analysis, and then people that can specialize in testing, deployment, maintenance, and so on and so forth. So we have 7 stages in the software development life cycle. I want you to re-echo it after me. Number one, planning. Number two, requirements gathering and analysis. Number three, system design. Number four, implementation of coding. Number five, testing. Number six, deployment. Number seven, maintenance. I want you to say it after me again. Number one is planning. Number two, requirement gathering and analysis. Number three, system design. Number four, implementation or coding. Number five, system testing. Number six, deployment. Number seven, maintenance. It is very important that you learn this at your fingertips. You learn it and be very, very acquainted with it. So we start dealing with each of the phases one after the other. So we have the planning phase. And so the planning phase is actually the first phase in the development life cycle, where you begin to think about is the point of inception of the project, or rather when you conceive the idea about the project. Now, when you conceive the idea about the project, one of the questions that will run quickly in your mind is this project workable? What is the feasibility of the project? And then when you continue pondering over the feasibility of the project, it is necessary that you need to bring up a pen and a paper, and then you start writing or the things that can maybe form the basis for your planning. Number one is the scope. What is the scope of this project? And this has to be defined because software development has a way of maybe growing out of, or rather scaling out of scope. Okay, it has a way. So number one is there is the need for the feasibility of a project lies in understanding the scope of the project, because when you don't have adequate scope to your project, you may not be able to manage the resources that are available to you, and then you may not be able to deliver on budget because it is your scope that will define the project. Are we together? It is your scope that will define the budget. And your scope has also an impact on the timeline. When I talk about timeline, we're talking about the time it will take to deliver the software. So all of these things are the things that you're going to be looking at the planning phase. So you look at, is this project feasible? To what extent are we supposed to deliver this project to? What are the resources at our disposal in delivering this project? Is our budget able to carry the project? And then when are we expected to deliver the project? These things are the things that one needs to be able to pen down and then to write it down. So the basic aim here is to ensure that the project has clear objectives and that its development is very, very viable. The activities in this stage will include conducting feasibility study to assess the technical, financial, and operational viability of the project. So, what we do in it is to define the project goals, the project scope, the risk. We need to assess this risk, put them down, develop a high-level project plan and timeline, and then allocate resources, estimate costs, and create the budget for the project. Are we together? This is very, very important. This is very, very important. And as I'm bringing this to you, I want to beg you not to learn by, or rather, not to learn by experience. Okay? What I mean, do not allow experience to teach you. Maybe when you are delivering a large, or when you are delivering a work, and then experience will begin to teach you that you did not define your project goals. In other words, as you are working, you are looking at, you have a scattered view of what you want to develop. Number two, you don't know where to end a project. You begin to include features and features and features and features, and then you may be even be generating other features that have never been implemented before. Okay, and also you may not be able to assess what your risks are. Okay, why am I very much interested in delivering this topic? Because I would not want you to face the same problem that I faced, or to enter into the same problem that I entered into while trying to deliver a project. So it is very, very important that you take time to plan out uh, the work you want to do. You need to take time and do a very deliberate plan, draw your timeline, have an understanding, define what the risks are trying to deliver this project, define your project goals, and then put them in writing. Remember, even the book of Habakkuk in the Bible says that the vision is set for an appointed time. He says, if it tarries, wait for it. And he gave instruction. He said, write it and paste it. So there is something that you are going to write. There are project goals that you are going to actually be very deliberate at defining. Okay. Now, number two is requirement gathering and analysis. Okay. The goal of this phase is to gather and document the functional and the non-functional requirements of the project you want to deliver. Okay, you need to have an understanding of that. Now, the functional and non-functional requirements are going to be gathered through a field survey. Okay, the team must ensure that all stakeholders have a clear understanding of the system that you want to develop. Now, you want to develop rather. Now, when we talk about stakeholders, we're not just talking about the team doing the work. The customers are very important. The users and the project managers are also very viable project stakeholders that you need to gather requirements from. And when you are meeting them, you are sourcing from them, rather trying to elicit what they would want this project to be like and what the outcome of the project is going to be like. So when you are doing this elicitation, you are you are writing them down. You are writing them down. Okay. Now, in the first phase, you may not be the software developer, or the team may not be actually, of course, when we talk about the team, we've said that the team also includes the client. So basically, in this first phase, the person that does this also is, first of all, the client, who knows, or rather, who sees who sees a need for a software solution for his work. Okay, so he starts it out, and then when he brings it to the project team, the software requirement engineer is going to be part of the team that will make further contact or conduct um, from further interview from the users or the project manager and the customers, in order to find out what the requirement specification of this software is going to be like. And upon interaction with the customer, the users, and the project managers, is putting down something on the software requirements document. Yeah, software requirements specification document is putting down something, is noting down something. Okay, so after that, you will perform a thorough analysis of the requirements in order to ensure that the requirements that is going to meet the goal of the software to be developed is actually complete, clear, and consistent. Okay? It has to be complete, clear, and consistent. And this, at this point, has to be validated by the stakeholders. In other words, when they have finished interacting with the requirements engineer who has elicited uh, some functional and non-functional requirements of the software based on the software goal, or rather, yeah, the software goal, the thing that the software is meant to achieve. Okay, when he has finished eliciting those information and putting it in a requirements document, is going to be able to, before they begin to work on it, or rather before the team begins to work on it, it has to be validated by the stakeholders. In other words, let me take for instance, you want to have a building designed for you. You go to an architect, you consult an architect, a consultant, okay, and you discussed with him. You said, I want two-bedroom flat with this and that and this and that. The architect is going to make a plan. In other words, from what you said, is going to improve on it, make a plan, a documented plan, and then bring it back to you for endorsement. Okay. Now, why is he bringing it back to you? He is wanting to be sure that your mind concerning the house you wanted is actually what he has put down. Now, when you validate it, when you validate this is what I want, then further work can be done based on the understanding of the functional and non-functional requirements that you have elicited from the stakeholders. Okay, see, so this is what happens at the requirements gathering phase. And there are several ways that you can use to gather information in this age, in this stage. Okay. Okay, now the next one is the system design phase. So in the system design phase, the systems architecture and design are developed based on the requirements that has been outlined in the software requirements specification. So the system now the design system will now specify how the system will be built, and it will focus on the overall structure of the system, the user interface, the data flow, and the data based design. Okay, in one of your courses, you may be taught now. Of course, you are going to be taught how to make some design. There is a course of object-oriented design, and if I get that course correctly, software design or something like that. Okay. So you are going to be dealing with all of these things. So the key activities in the design is the overall development of the software architecture, the system architecture and design. Okay. Then you talk about the database design, talking about the interaction and between the elements of the database, whether the linkings that has to be in the database, the normalization of the database, and so on and so forth. So those are the things that we have to talk about there. You talk about the data structures and then the user interface. When you are done with this development, the design, the interaction of the system is at this point also developed. Now, some of these designs are implemented using UML diagrams, okay, to show us there is the UML diagram, and then there's the entity relationship management diagram, okay, that you will have to develop. Okay. So So the deliverable from this stage is going to be a high-level detailed design document that will include architectural diagrams, data flow diagrams, DFDs, and database schema, and so on and so forth. There might be use case diagrams and sequence diagrams, class diagrams, and so on and so forth. So those documents, those technical documents are going to be guide for the people that are going to implement the design. So first of all, the design is done on paper, okay? The design is done graphically, and the interaction between the objects in the software can be clearly seen on paper before an implementation is done. Then the next point now we'll now see is the implementation or the coding phase, that's development phase. So at this point in time, the developers will now begin to write codes in specific programming language that they choose to implement the software project on. So we have the development, which is coding and implementation phase. Okay, at this point, the language to be used will depend on the choice or the one available, uh, or depending on what the stakeholders require for their work. Maybe in their system they have been working with some specific languages, okay, or tools. Okay, so at the end of the development phase, what we see as a deliverable is the fully developed software model or application. Okay, that is what is seen as the deliverable. Now, if this application has been fully developed, the next point now is going to be the testing of the application. So the testing of the application ensures that the developed software meets the required standards and works as expected. Now you are going to supposed to be putting one and two together to know the person or the personalities in the team that we studied last time that will have the responsibility of conducting each of these phases where their work are specifically placed in each of these cycle of software development. Okay, at this point in time, you will notice that the quality assurance engineers are at this point going to swing into action, matching the output of the implementation with the requirements that were gathered or that were established in the software requirement specification document. Okay, so the major activities here include conducting different types of testing, including which will include the unit testing, integration testing, system testing, and finally the user acceptance testing. Because it is possible that you have developed a software that has passed unit testing, integration testing, system testing, and then the user may possibly not accept the software based on some certain things. So identifying defects or issues and correcting them is one of the key roles, key activities that will be done here. Validating the system performance, security, and functionality, and regression testing to ensure that new changes don't introduce new bugs, and so on and so forth. Now, when you are finished testing and the system is certified to be used, the next thing that we now have is deployment. Now, what do we mean by the word deployment? Okay, deployment is simply to release the software for the end users to use. So this phase may involve several sub-steps such as installing the software, configuring the system, and conducting a final round of testing in the production environment for maybe cloud based software or even desktop software, and sometimes may include hosting when it has to do with mobile application or web application. Okay, so basic activities will be just to release the software to the production environment. Okay, then conducting deployment checks such as final testing and configuration, and monitoring the system for any issues during deployment is one of the things that has to be done. Now, finally, in the cycle is maintenance and support. Maintenance and support. This phase begins once the software is live and in use. Okay, the moment that software has been released for use, any other operation that may be done on that software is actually regarded as maintenance or support. So it will involve the system. It will involve looking at the system and consistently monitoring the system for any defects or improvements and updating it as necessary. Okay. Now, for instance, it is possible you deploy a web application and you may have some certain bandwidth are allocated to you. And then along the line, you just discover that your website have started gaining traction and incidentally, because of maybe the number of bandwidth or the amount of bandwidth that was allocated to you based on the number of visitors that the website starts attracting, you may start noticing a kind of a drop in the you may kind of start noticing a drop in how the system responds. Okay, so it may call now for either an improvement or rather an upgrading on the hosting type or hosting package that you are using at the moment in order to accommodate the increase in the number of users that have started making use of the website. Excuse me. So, in summary, the software development lifecycle is a comprehensive step-by-step process for delivering high-quality software that meets user needs and expectations. So, each phase usually plays a very vital role in ensuring that the software is well planned, well designed, thoroughly tested, and maintained over its lifetime. Okay, so at this point, we are done with the 7 phases that we have in software development lifecycle. Now, let's look at the importance of adhering to a structured software development lifecycle. I think in some of these, I've actually touched them in passing. So, adhering to a structured SDLC is very, very critical for successful development of software projects because it will provide a framework that will help the team to manage the complexity of the software development while still ensuring that a quality software is released. Now, we look at reasons why it is necessary to be parochial in following the software development lifecycle. Number one is that it will help you to effectively manage the project. Okay, it will help you to effectively manage the project. Now, when you create a clear roadmap for the project and outline specific deliverables for each time and the timelines and the objective, it will make it easier for you to know when you are lagging. For instance, you stated to yourself that you are going to finish this software development or this project in 6 weeks, and then you divided the project into sprints, and then you say in the first sprint, maybe your each sprint is about 1 week, and then you say in the first sprint, I'm supposed to cover so and so, and all of these timelines were developed based on the project scope, project objective, based on the budget and so on and so forth, so that you will make sure that you do not use extra resource to service the development of that project. You outlined it in weeks, and so it will now help you to know what is supposed to be covered in each sprint, and then to ensure that all the team members work together to ensure that the deadlines did not that they did not miss the deadline for each of those deliverables that has been earmarked. Now, in that improved project management, this seemed to be the mother of all of them, because for there to be improved project management, there has to also to be a better resource allocation. So when you have actually planned this work very well, it will allow the project manager to be able to properly allocate human, technical, and financial resources more effectively. So, in other words, each phase we have that has its own requirements must be properly planned for, and the resources must be properly allocated for such a phase, to avoid either over allocation of resources or underutilization of resources. Take one example. Okay, now if maybe the system was not properly, maybe a project was not properly planned, it is possible that you may spend more fuel, maybe the energy that you are using to deliver. Let's take, for instance, you do not have the national grid and you have to suffice for your generator. If you do not plan very well, you may find out that at some certain times you may be burning diesel in your generator that you are not supposed to burn. Okay. So, or rather, let me just take for instance again, maybe you made a shabby plan that when you on your generator, when you put on your generator, it is only one person that is working on the laptop, and then the fuel is wasting. Now, if you understand all these things, you will better uh, allocate your resources very well, so that you wouldn't be burning your fuel, your generator fuel, in vain, and then just few persons may be using it, and so on and so forth. I don't know if this explanation, this example, made sense as it concerns better resource allocation. Okay, so by adhering to the phases and processes in the software development life cycle, teams can better control the cost. This is very important. Can better control cost. Now, if you did not maybe plan very well, the project that you're supposed to finish in 6 weeks may end up finishing in 6 months. And you know what the implication that will make, the implication of that particular mismanagement on the control cost of the project. So the planning and the design phases will allow for accurate cost estimation, reducing the likelihood of budget overruns. Okay, then next is enhanced communication and collaboration. When there is a structured SDLC, the stakeholders involved at different stages may better be able to communicate with each other. So regular communication with stakeholders now will ensure that uh, the project aligns to the business objectives and the technical outcomes. So with well-defined phases and clear deliverables, different team members, such as developers, testers, designers, business analysts, can collaborate more efficiently, thereby reducing the misunderstandings and delays that usually uh, comes in systems where there is no proper planning. Okay. Now, another reason why it is necessary is so as to present high software quality. Okay. A structured SDLC includes rigorous testing at various stages. Now, these testings actually designed, it's actually designed that there's going to be, in fact, there is a design on how to, because when you have developed the system and there are functional and non-functional requirements, okay, now that document is going to serve as a script that will aid the testing. Now, if you are testing a work without a script, it means that there might be some certain functional areas that you may omit, and that may introduce a vulnerability into the system. Okay. And then the system may be vulnerable to attack because it was not properly tested. So the essence of this is to ensure that bugs are detected early and are fixed before the software is actually deployed. Then the next one is better risk management. The phased approach in SDLC enables early identification of risk, such as technical challenges, budget overruns, or unrealistic timelines. Now, when you are making a timeline and you just, maybe somebody came to you and say, please, I want you to deliver a software for my company and this and that and this and that. And the person will quickly tell you, I want it in 2 weeks. And then because you needed money, you may just accept that you want it, you are going to develop it in 2 weeks without first following the process, of SDLC. Because when you have now developed these things when you have now earmarked timings to these things and allocate time for these things, you may certainly discover that although it is necessary to deliver this work on time, but 2 weeks may not be feasible. So it will help you to manage the risk that is associated with budget. You know, when somebody tells you, I want you to do this work in 2 weeks, and then you still end up charging the person very high, you see, it will not make sense. Okay? It will not make sense. But if you are able to maybe properly allocate timing to that work, and maybe you end up telling the person that 2 weeks is not that 2 weeks is not viable, but maybe 3 months is going to be viable. And then from that 3 months, when you now maybe state what the budget is going to be like, I think it will be more appreciated than, let's just say you want to do a work for 2 weeks and you charge the client for 2 million, and the client is now saying this is this and this is that. Is it not something that you will just do in 2 weeks, and so on and so forth? But if you end up telling the client, based on your calculation, that this thing can be done in maybe 4 months, if you say the same 2 million or 3 million, the person may not say much concerning that. Now we look at increased customer satisfaction. So when requirements are carefully adhered early in the SDLC, developers can ensure that the final software product meets the needs and expectations of customers. So a structured SDLC often includes review points where stakeholders, including customers, can provide feedback, ensuring that the software aligns with their expectation throughout the development process. Next, we have predictability and control. So since each phase of the SDLC has a specific timeline. The overall project timeline becomes more predictable. You can say, okay, this project is going to go live on so date. Okay, it is possible to predict that. Okay, and this will make it easier to manage customer expectation and to deliver the work on time. So a structured SDLC has clear milestones and checkpoints that enable teams to measure progress and make adjustments if a phase takes longer than expected. Okay, now it also makes for better documentation. SDLC processes require proper documentation at every phase, from requirements gathering to testing and maintenance, so on and so forth. This documentation serves as a reference for developers, testers, and future maintenance teams. Okay, next we'll have high flexibility. In some SDLC models like Agile, a structured approach allows for iterative development, which can easily accommodate changes in requirements or new insight as the project evolves. Okay. This ensures that the software remains relevant and useful as business needs change. A structured SDLC can help scale the software efficiently as new features or functionalities can be integrated systematically without disrupting the core system. Then, finally, we have compliance and legal considerations. Many industries, like the finance industry or healthcare, many of those industries require software that will comply with specific regulatory standards. For instance, systems that talk about the privacy of the users. So a structured SDLC will ensure that these standards are considered during design, during the development, testing, and in other words, it will help to avoid maybe legal and compliance issues. So when you sit down, you make sure that nothing is omitted from the principle, rather from the inception, that's from the planning stage even to the ending stage. So incorporating security measures and compliance checks into the SDLC will ensure that the software adheres to data protection laws. I think I've mentioned this in passing. Okay, and then minimize the risk of data breaches. Okay, I think this is the end of the class. If you have any question, please use the right channel to send your questions across. Okay, thank you very much.